Hey everyone, in this video we'll be talking about how to find the extrema of a function. So the extrema of a function is a term for both the minimum and maximum values. So we're going to be finding the minimum and maximum values. And when you're talking about minimum and maximum together, just a shorthand way of saying that is extrema. Extrema just means minimum and maximum values. So we'll be looking at this graph first. We'll be looking at this function drawn in orange, f of x. And the first thing we're going to do is identify where this function is increasing and where it's decreasing. So if you take a look at the left part of this function first, so where it starts at -5 right here, you could see that this function goes up. It's increasing. So if you follow it along here, it increases until this point right here at -3. So right here, where x equals -3, it actually stays flat. So it is flat right here. And then from this point on, right after -3, you could see this function starts to go down. So it decreases. So it decreases all the way up until -2, right here. At -2, it becomes flat again, and then it increases from this point on. This function starts to go up, so it increases all the way up to +2 right here. Right at x equals 2, it's flat again, and then it decreases. So if you follow the function again, it goes down, it decreases until 4 right here. That's where it's flat, and then it begins to increase right here, all the way to +6. So as you can see, this function increases, decreases, increases, decreases, and then increases. So this function changes a lot. And the important part is where the function changes from increasing to decreasing. So right here, it's increasing right here from -5 to -3. And then it decreases right here from -3 to -2. The flat line where this function changes, this is an extrema, right here. So where it changes from increasing to decreasing, this right here is called a local maximum. So this function f of x has a local maximum at x equals 3, or at x equals -3. So at x equals -3, there is a local maximum right here, where it changes from increasing to decreasing. And you can kind of see why it's a local maximum is because this is where the function reaches its highest point within this vicinity. So if you just take a look at, if I draw a rectangle right here, so if I go ahead and just rectangle all of this piece, if we only look at this area right here, this function reaches its highest point right here at x equals -3, and then at y equals -1. So that is a local maximum. And a local maximum is just where the function changes from increasing to decreasing. Now, what about the other way around? What about if the function changes right here from decreasing to increasing? Well, right here, as you could see, we identified another flat line. And this point right here is called a local minimum. So this is called a local minimum. And the local minimum over here occurs at x equals 4. And of course, we can also find f of that function, so f of that input. So f of 4 equals, as you can see right here, f of 4, the y coordinate is 0. So f of 4 is 0. And same thing here for this local maximum we found earlier. What's f of -3? That is right here, -1. Okay, so far we found a local maximum and a local minimum. Can we find any more? Well, there's actually another local maximum right over here, right here. So this right here is another local maximum because the function changes from increasing to decreasing right here. So there's a local maximum right here at x equals 2. So x equals 2, there's another local maximum. So local max. And there's another local minimum right down here. So this is a local minimum because right here, the function changes from decreasing to increasing. So that is a local minimum. So local min, that's a local minimum. And that's where the function changes from decreasing to increasing. And it occurs at x equals -2 right here. At x equals -2. So we found all the local minimum, all the local minima and all the local maxima of this function. There are 2 local minimum values and 2 local maximum values. But now we're going to introduce another concept. So we know the local minimum and local maximum values occur when the function changes between increasing or decreasing, or increasing or decreasing. So just put another way, if the function changes from increasing and then decreasing, at the point at which that function changes, that will give you a local max, a local maximum. And then the other way around, if it changes from decreasing rather, so if it changes from decreasing to increasing, that will give you a local minimum. So that's very important. But now we're going to introduce another concept. What if we wanted to find the lowest and highest values of this function? What is the highest value f of x could be? And what is the lowest value f of x could be? So let's start with the highest value. Just from looking at this graph, what is the highest that this function can go? Just looking at this orange curve, what is the highest value? Well, if you take a look, the top value occurs right here at this point. It occurs at this point. This is 6, 4. Just looking at this graph, this is the top value. Right here, it's 6, 4. So at x equals 6, and then f of 6 equals 4. So this is the highest value, and this has a special name. This is the absolute maximum. So this is the absolute maximum. So that's the absolute maximum. Great. And then now we want to find something else called the absolute minimum, and that would be the lowest value of f of x. So what is the lowest point f of x could be? And just looking at this graph, the lowest value occurs right over here at this point, -5, -3. And this right here is called the absolute minimum. So this is the absolute minimum right here. So those are all the extrema that you need to know. There are the local minimums and the local minimum and maximum values, and there is the absolute minimum and absolute maximum. So what makes this local maximum right here local is that it is a maximum only relative to where it is, but it's not the absolute maximum. The absolute maximum over here is the highest value in the entire function. It's not just a local maximum where this is just the highest value relative to its position, just right here. It happens to be the highest value right here in its area. The absolute maximum is the highest value in the entire function. And same thing with the absolute minimum. The local minimum is just the lowest value in that part of the function, just that area. But the absolute minimum is the lowest value in the entire function. It is the lowest the function can get. So that's the difference, and that's how you find the extrema of a function. And let's go through one quick example with a parabola. So let's go ahead and just graph a quick parabola, f of x equals x squared. So if we wanted a graph of f of x equals x squared, let's go ahead and just label everything. -3, 1, 2, 3, 1, 2, 3, 4, -1, -2, -3. Let's extend this a little bit, -4. Okay, so to graph this parabola, we start at 0, 0, 1, 1, 2, 4, then -1, 1, -2, 4, and then this parabola is going to be curved like that. Let me just go ahead and do that. And it's going to be curved the other way too, like that. Okay, so we have this parabola, f of x equals x squared, and we are going to find the extrema of this. So first right here, let's identify where it's increasing and decreasing. So if you look at this function right here, just starting from the left, you could see it's going down. So it's going down, so it's decreasing right here. And then at this point, it flatlines at the origin, 0, 0, and then it begins increasing from this point on. So this point right here, you could say is a local minimum because it decreases then increases. But this point is actually also 0, 0. This point is actually also the absolute minimum. And the reason why it's an absolute minimum and not just a local minimum is because this is the lowest value that f of x could be. This is the lowest value. Just looking at this graph, the lowest point it hits is 0. It can't reach any of the negative numbers. It doesn't go lower than 0. F of x equals x squared. So that's why this is the absolute minimum. It is the minimum value that this function could be. And as you can see right here, there's no local maximum and there's no absolute maximum on this parabola. And the reason why there's no absolute maximum is actually because if you look at these arrows right here, so let me just highlight these arrows. This graph doesn't have a highest point. This graph goes to infinity in both directions. It just goes to positive infinity. So because this graph can go to positive infinity all the way up, there is no absolute maximum value. So f of x equals x squared, there is no maximum value. It just goes to infinity. So there's just an absolute minimum value, and that's the only extrema that we have for this function, f of x equals x squared. So that's how you find the extrema of a function. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.